Okay, this is section 10.3 in MathLinks 8, two-step algebraic equations with fractional coefficients. We're going to start here today on question 6b. We didn't have to do 6a. We're going to just model 6b. And the reason why I like modeling 6b is because it's not a negative coefficient, which makes modeling so much more weird. But we're going to model it this way anyway. So we have a negative 3 is equal to, or is balanced with, 7 plus a fifth of x. So right there we have a fifth of x. So this equation over here can be modeled symbolically as this. Now when we have two-step equations, now you should know by now, Wyatt, that when you have a two-step equation, what's the first thing you should always get rid of? What's that called? I'm constantly reminding you about it. Constant is correct. And what is the constant in that equation? Anybody? 7. And how do I get rid of a 7? I get rid of an adding of 7 by subtracting 7, right? The opposite operation. Now some people get confused and they think it's the opposite number, and it kind of looks like that. But what we're really doing, that's adding 7 to that side, and now I'm going to subtract 7, which is the opposite number. It's still 7, but it's just the opposite. And I'm going to put subtracting 7 on both sides, which is represented with this. So when we do that, the reason why we put that is because it creates 0 pairs. My next picture is now just a fifth of x is equal to, there's now 10 of these, so I'm going to just do like this. I'm going to just do negative 1 times 10. Now once we have that, Wyatt says we need 5 of them. So what I'm going to do, if I was to actually, and the word is not, that's doubling, that's tripling, that's quadrupling. And this word here, does anyone know what it is to multiply it by 5? Quintupling or quintupling. So if I quintupled that side, in order to keep it balanced, I would also have to quintuple this side, so negative 10 times 10. And these 5 fifths of x, when put together, will make a full x. And over here, those 10 negatives quintupled will make not 10 of them, but 50 of them. And this says negative 50 is equal to x. That's our solution for question B using just modeling. Okay. And actually, if we go back to it and just follow this one through, if I was to do that, subtract 7, I have negative 10 equals a fifth of x. I multiplied it by 5 and I multiplied it by 5. And I got x is equal to negative 50. What you're asked really in the grade 8 outcomes is to be able to understand that both of those methods are the exact same thing, right? The symbolic representation and the numeric representation. Our next question is question 8. Sorry, so now we're on question 8 and 9. And actually 8 and 9 are the same thing, so we're going to do 8 and 9 at the same time. Because question 8 says, what's the first thing you would do to both sides? And question 9 says, what's the second thing you would do to both sides? So in question 8a, what's the first thing we would do on both sides? Wyatt would tell you, you got to get rid of the constant. So you're going to subtract 12 from both sides. And in keeping with just 9a for a second, what would be the second thing? Once this is gone, what would be the second thing you would do? You would then multiply both sides by negative 5. In B, the first thing you do would add 2 to both sides. The second thing you do is multiply both sides by a positive 13. In C, the first thing you do is subtract 6 from both sides. And the second thing you would do, now this is tricky, because if you look at that, it's not written the way we're normally seeing it, correct? So what should I probably rewrite that as before I actually determine what I'm going to do to both sides? I want to rewrite that like this, because they're both the same thing, right? So what would be the second thing you would do with C? Is you would multiply both sides by negative 12. And I'll guarantee you, over half of you have it wrong. Half of you probably say multiply both sides by 12. But if you did multiply both sides by 12, you'd have this left. And then the last thing would be dividing both sides by negative 1. And finally, oh yeah, you'd have to divide both sides by negative 1. So just rewrite it first. And then D, first thing we would do Thank you. And subtract 11 from both sides. And the second thing we would do is what? Again, we have this thing that's going to be written like this. So we want to rewrite it like this. And what's the second thing we're going to do? We're going to multiply both sides by -3. Okay, that's the answer to those ones. So we can skip 9 and we go right on to 10. It says solve each equation, verify your answer. So we're going to use opposite operation for this. So we're going to solve this with opposite operation. I'm going to subtract 2 from both sides because we know that we have to get rid of our constant first. Once we do that, we're going to have m over 3 is equal to 16. We're then going to multiply both sides by 3. And we're going to find our solution of m equals a positive 48. For b, the first thing we're going to do is add 8 to both sides to get rid of your constant. I have c over -8 equals -4 left. Multiply both sides by -8 to get rid of dividing by -8. And c will equal a positive 32. In question C, first thing I do is subtract 9 from both sides. 7 will equal b divided by -8. Multiply both sides by -8. And b will equal -56. And finally, your last question. My constant is 19, so I'm going to subtract 19 from both sides. I'm going to be left with a -7th of n is equal to -22. Multiply both sides by -7 to get rid of the divided by -7. And n will equal 140 and 14 is 154. Positive 154. We're going to go right on to question 12. And question 12 says, is n equals -72 the solution to each equation? So there's two ways you could solve it. You could actually take A, and you could just solve it if you wanted to. And if you solved it, n equals 72 is not -72, so I could say no, n is not -72. But there's a better way to do it. And what is that better way? It is simply through substitution simplification using BEDMAS. So if I take my expression 6 plus a ninth of n and substitute instead of n the number -72. If I simplify this expression and its value is 14, then I know that this solution is -72 for n. But if it's not, then I know that n has to be a different number. And we already solved it, so we know it's different. But you would get 6 plus a -8. Is that right? Did I copy that down right? Yep. And it would be -2. So if n was -72, this number over here should be -2, and it's not. It's 14. So therefore, we can say no. For b, same idea. Take the expression, substitute the n for -72. And if this expression simplifies to be a positive 2, then we know we have the correct solution. So 14 plus 72 divided by 6 is 12, but it's going to be -12. And a 14 plus a -12 is a 2. And since it does equal 2, then for b, I say yes, n equals -72 is the solution for that one. For C, substitute -72 for the n. How many 73 is 24? And 24 plus 6 is 30. So in this one, it actually says -18 instead of 30. So I can say no, -72 is not the solution for C. And finally, n divided by 36 minus 15 would be -2 minus 15, which is -17. And since -17 is the value on the other side, I can say yes, -17 is the answer. Now for question 13, we get into story problems, and of all the story problems we have to do, this is one of the easier ones. And the reason why it's easy is because it is telling you what the variable is, and it's telling you what the other variable is. So it's telling you there's two variables, and it defines them for you. It says that S equals hours of sleep, and it says A is the age in years. So it's done that work for you. And it's also gone out of its way to actually give you the equation. The hours of sleep you need will be equal to 12 minus your age divided by 4. Okay? So the formula is given. The easiest part about this is all you have to do is read the question and figure out what information is given, and you substitute that in to your formula. So it says, question A, if 10 hours of sleep is the amount of sleep Brian needs, how old is he likely to be? So between these two variables, which one are we searching for, the A or the S? How old is he likely to be? We're looking for the A, right? Because if he gets hours of sleep is given. So if I put 10 here, that's how many hours of sleep he is getting. That's how many hours of sleep he needs. And if I substitute that into my formula, I now have a two-step algebraic equation I can solve to figure out how old he is in years. So I'm going to subtract 12 from both sides to start. I get negative 2 equals. And remember, when we have this, you could write it any of these. Oh, that's so good. Any of these ways here. We're going to choose this one. So we're going to write a negative quarter of A. And once we do that, we're going to multiply both sides by negative 4. And it'll say A equals 8. Now, some people will just leave it there, but I need you to know, or I need you to tell me what that actually means. So for the story problem, if A equals 8, and A represents his age in years, then Brian is 8 years old, according to the formula. If we look at B, B gives us Natasha, which is different than the Brian question. It says, Natasha's 13. If she gets 8 hours of sleep each night, is this enough? So what I'm actually going to do here is I'm going to take this formula, S equals 12 minus a quarter of A, and I'm going to substitute Natasha's age into it. So I'm going to put the hours of sleep Natasha will need is 12 minus her age, which is 13, divided by 4. So all I did was I substituted her age, 13, into my formula. And now I'm not going to actually use algebra. I'm just going to use BEDMAS to simplify that side to see how many hours of sleep she should get if she's 13 years old. So I'm going to do my division first. So it's 12 minus a quarter of 13. If I divide that, it's actually 3.25. And then take my calculator and say, what is 12 minus 3.25? And the answer is 8.75. So without using algebra, just BEDMAS and substituting Natasha's age, I've determined that if Natasha's 13, using that formula, she needs 8.75 hours of sleep, or 8 hours and 45 minutes of sleep, because 3/4 of an hour, or 0.75 of an hour, is 45 minutes. If she's getting 8, is she getting enough sleep? No. How much more sleep does she need? She needs another 45 minutes of sleep each night. Our second story problem says the cost of a concert ticket for a student is $2 less than 1/2 of the cost of an adult ticket. The cost of a student ticket is $5. Let A represent the cost of an adult ticket. So the first thing I'm going to do is A equals an adult ticket. And we know from experience and from this question that an adult ticket is more expensive than a student ticket. So in terms of balance, it is, if we want to say a heavier amount or a larger amount than a student ticket. So it's a higher amount than the student amount. So from a balance standpoint, it's tilted towards the cost of the adult ticket. So what we're going to do is we're going to manipulate this A variable. And what our goal is to get the scale to be like this. So we're going to manipulate the A value so that the A value and the S value are the same. So it says the cost of a concert ticket for students is $2 less than half of the cost of an adult ticket. So is this true? If I take half of the cost of an adult ticket, is that true now? Half the cost of the adult ticket is now the exact same price as the student ticket. No, because this is a student ticket. The cost of a concert ticket for a student is $2 less. This is now $2 less than this. So how do I get it to be even if this is $2 less? I have to subtract 2. And now they're even, right? So now the cost of a student ticket and the cost of an adult ticket is the same. So if I say the student ticket, well, I already know the student ticket's price. How much is it? It says the student ticket is $5. So now I have an algebraic expression that I can create an equation. So that $5 is equal to an adult ticket, half of an adult ticket minus 2. And when I do this, I can isolate the variable by adding 2 to both sides. Half of an adult ticket is $7. If I multiply both sides by 2, an adult ticket is therefore $14. So therefore, an adult ticket is $14. And our last question is actually kind of an easy question as well because it gives you the formula. 14 was actually the hardest question, even though 15 is after 14 is usually harder the higher the number of the question. It says in the following formula right here, T is the air temperature in degrees Celsius at the altitude of h meters, and the T is the ground temperature. So what this means is, I'll draw a picture. Here's the ground and here's the airport where they have the, I don't know, they have the little tower there and the planes are on the runway. And up here is the plane. Okay? So what it says is T is the air temperature in degrees Celsius at an altitude of h meters. So your altitude or your height is h meters. The temperature outside the airplane is capital T, and the temperature on the ground is small t. Now the expectation would be after reading that paragraph you all could figure that out. But the reality is a lot of you had difficult time figuring out what that actually said. But that's what it means. The temperature outside the aircraft is capital T, the temperature on the ground is small t, and the height of the aircraft is h. So we have our formula. The temperature outside an aircraft is equal to the ground temperature minus the height of the aircraft divided by 150. That's a real formula. Okay? So we're going to take that formula, T equals small t minus h over 150, and we're going to try and solve A and B using that formula. For A, it says if the ground temperature is 25 degrees Celsius. By the way, which one is our ground temperature again? Big T or little t? Little t. So if that is 25, I'm going to substitute that for 25. If the ground temperature is 25 degrees Celsius, what is the temperature outside of an aircraft? That's the capital T. If the altitude, oops, daisy, let's try that again. Smaller brush. If the altitude is 7,500. So in A, it gives me 2 of the variables, and it does not give me the third variable. Am I going to need to use algebra to solve this? No, because T is already isolated. So I don't need actually algebra sense whatsoever. I just need BEDMAS sense. Am I going to subtract or do division first? Division. So I'll grab my calculator, say what is 7,500 divided by 150? And the answer is it's 50. So 25 take away 50 is the outside temperature. So the outside temperature, 25 take away 50 is not 25. It's negative 25. So for A, therefore, the temperature outside the plane is negative 25 degrees Celsius. Okay, that's for A. And for B, the different question, it says, what's the altitude of the same plane if the outside air temperature is negative 35? So I'm going to write my formula down again. T equals small t minus h over 150. But this time, what am I looking for, the big T or the little t? If it's looking for the outside air temperature of the plane, we're looking for the big T. No? Yes, no, sorry. We already know that. We know that to be negative 35. So the outside temperature of the plane is negative 35 degrees Celsius. So that's our big T. That's the temperature out here. And we're looking for the small t. So we're going to keep that small t. Now, if it's the same plane, what's its altitude? If it's the same plane, 7,500 meters, the same plane, right? 7,500 over 150. No, sorry. Is that right? Oh, I screwed that up again. My bad. I'm going to go all the way back because I screwed it up so bad I have to go back right to the beginning. Oopsie daisy. What is the altitude? So I don't know my h. I do know my outside temperature is negative 35. And if it's the same plane, it's still 25 degrees on the ground. That's how we're supposed to do it. Sorry. That's the solution. Outside air temperature of the plane's minus 35. Ground temperature is 25. What's the altitude? So I'm going to get rid of my constant first by subtracting 25. Negative 60 equals h over negative 150. Oh, I did this wrong too. How did I screw this up? Did I screw this up? Yes, I did. No, I didn't. No, I didn't. Now I'm going to multiply both sides by negative 150 because I'm looking for altitude. I've only had one coffee this morning. And h will equal the product of negative 150 and negative 60. Negative 150 times negative 60, it's positive 9,000. So therefore, the height of the plane is 9,000 meters. Or if you want to get really smart, 9 kilometers.